Okay, I'm gonna work this one. This will be example number 2. And then I'm probably going to flip through your book and see if I can find another one that doesn't have this nice number. I think I maybe did a problem from I can do a problem from your test review or something. But anyway, so let's work this one. So I'm going to work this one. We're going to finish with the stack crunch. So we're going to go through the process that we did a while ago. Remember, the first thing we need to do is we need to draw a picture. And this asks for a 90% confidence interval. Okay, I'm just guessing where the 90% goes. I know it goes in the middle though. That's 90%. So this is the area that I'm going to be using right here. But remember, we need this to get that critical value. And this is the Z thing. So this is 0. Okay, so how do I calculate this? Remember, I do 1 minus 90 divided by 2. So 1 minus 90, that's 10% divided by 2. So that's 5%. So my area that I'm looking for right here, the area to the left, that's 0.05. Now, I went ahead and did that because I want you to practice doing that. And when you go over here, you're going to be looking in, you're going to be looking in the middle right here for 0.05. So 0.049 is going to be right there in the middle. Do you see that that says these two things right here? This says 9.5. So I'm 5 of those away from being 5, and I'm 5 over. So it's right smack dab in the middle. It should be right here. Okay, so what number is that? Let me get a different color highlighter. It is negative 1.6, and it's halfway between 6.4 and 6.5. So what's halfway between 4 and 5? It would be 0.045. That's what it would be. That's halfway between those two. And that's where we would go up. Okay, now that's why it gets tricky. And yes, you can do this on the calculator too. And I will show you a calculator. And I'm also finding out, making sure that it's okay. I can share, I think I might be able to share with you guys a link that you can go to Texas Instruments and download the same version that I have right here, or for my high school kids that I use right here. Y'all can download this and use a free trial just like I'm doing. You see, this is a trial version, and my trial version is good for 90 days. So that would get you through the end of the semester. Anyway, I'm checking to make sure that I can do that before I actually, if I can, I'll put it on Blackboard for you. So I think it's negative 1.645 is what I think. If you look down here, here's 90%, 1.645. So we were actually right, 1.645. So the critical value, the Z value right here, is negative 1.645, and this one is 1.645. Remember, that's your critical value, 1.645. And why do we need that critical value? Because we use that critical value to find your margin of error. And the margin of error is this business right here. This business right here. Here's the margin of error. How far is it from here to here? And how far is it from here to here? There's your margin of error right in there. Margin of error right there. So we're going to calculate that, remember, by taking this 1.645 and multiplying it times the standard deviation over the square root of the sample size. Just dawned on me, we haven't even read all that information. So we need to go back up here. A student college admission doctor wishes to estimate the mean. See, this is what they want us to predict. They want us to predict They want us to predict the mean age of all students. That's the population. They want us to predict the mean of the population. So they want us to predict mu. All right. So that's how we know we're dealing with the confidence interval. In a random sample of 20 students. Okay. So N is equal to 20. Now we have to be careful here because 20 is not a number that's bigger than 30. So we have to read and make sure that our population is normally distributed. And there's where it says our population is normally distributed. So this is okay to be smaller than 30 because our population was normally distributed. The mean age of the sample, so that's the sample mean. The sample mean is 22.9. There's the sample mean. And it says from past studies, the standard deviation is known to be 1.5 and the population. Now, it doesn't say specifically, but it's implied right there that that is the standard deviation of the population. So they're giving us the standard deviation of the population. The standard deviation is known to be 1.5 of a normal population. So, and our C value right there is 0.9. And we'll need all of that when we go in a minute to type it in the StatCrunch. But to finish finding our margin of error, we take the 1.645, and remember how we calculated that. We looked this up we looked that up on the Z table. Okay. And then we multiply that times 1.5 divided by the square root of 20. All right, so we're going to go to a calculator and calculate that. You type that in a calculator, and it comes out to be 0.55. Use whatever calculator you use to type that in. It comes out to be 0.55. So that means that on our x-axis, and our x-axis is right below, I should move this down, but our x-axis is right below this one. Our mean is 22.9. Okay, and we're gonna go 0.55 in this direction by adding, and then we're gonna go minus 0.55 in that direction, and we will get our lower bound and our upper bound. This will be our lower bound, and this will be our upper bound. This number right here will be our upper bound. This number right here will be our lower bound. So 22.9 minus 0.55, that's 22.35. And 22.9 plus 0.55, that's 23.45. So for a 90% confidence interval, our interval is 22.35 and 23.45. Remember what this means? We are 90% confident that the population mean will be somewhere between 22.35 and 23.45. This is the confidence interval right here, and you can also write it as an inequality. Like that. Okay, now I'm just going to real quickly run over here to StatCrunch and see that And this is our old one, but I think it's fine. We can just go to stat. Remember, it's Z stats. How do we know it's Z stats? Because we know the population standard deviation. It's only a one sample, and we're doing it with a summary because we don't actually have a list of data. The sample mean in this problem, remember, was 22.9. And you're looking at this, of course. Your sample mean right here was 22.9. 22.9. This is the information that I'm putting in, 22.9. And the standard deviation was 1.5. And we know that we use the standard deviation for the population because we're using a Z summary. When we don't know the standard deviation of the population, we'll be using a T summary. Our sample size was 20, and we knew that that was okay because the population was normally distributed. We're doing a confidence interval, and this time it's a 90% confidence interval. We want it to go ahead and store it in the table and give us a confidence plot. And it put it underneath it over here. So here we go. It says that 22.3 and 23.45. So those were our two numbers. What did we get? We got 23.45 and 22.35. 22.3, that rounds up to a 5, 23.45. So we got the exact same thing. Oh, my dogs. We got the exact same thing that StatCrunch did. So I'm going to go ahead and stop this video. And this would be, you should be able to tell me everything. Our critical values were 1.645. Our margin of error was 0.55. Our confidence interval was 22.35 to 23.45. Here's what it looks like. So yeah, we've done everything here. This is just about anything that I could ask you. I'm going to stop the video, and then I'm going to use this I'm going to go get one out of the book that doesn't have a confidence interval that we can find at the bottom of this right here, because I want you to practice doing something that's like a 97 or an 82, because I don't want you to get too comfortable by looking on that one. Okay, so check the next video out.